Gotcha. Recording's going. So here we are, lesson 2. Good, good mild start in the first lesson 1. Lesson 2, of course, under course lessons, conditional statements and Boolean logic. We're going to learn about if statements, if-else statements, comparing strings, logical operators, Boolean variables, and how do you leverage them? You do this all the time. You wake up, if it's raining, call off work, or go to work, else stay at home, call off. If else statements. If your shoe's untied, tie it. If money in bank account, pay bills, have fun, else stay at home or work hard. You see, you do these kind of if else statements all the time. It's now codifying them is a little different, but Python's pretty straightforward. We'll have a good time with it. I got a group activity of where you compare some fluid ounces, greater than, less than, using comparison operators. Then you got a color mixer, which you could leverage or. Is equal to and or will help out there. Challenges, of course, use the links that are in the announcements. And then the lab 2 is the Python Rocks Amusement Park. And this is basically an admission by height is how much you'd pay to get in. So this is, less than 30 inches, you're free. All right, well, how could you code this with an if, else if, else if, else if, else if, else statement, right? Or something similar. And we'll learn how to do that this week. Of course, your quiz, bunch of other videos that break everything down. Feel free to check these out. They're a couple minutes long. This one's pretty long, 50 minutes. It's going to the group activity. But you have a couple that are 8, 3, 6, and 3, and 4 minutes. I try to keep those short just to get to the meat and potatoes of it and have a blast. But lesson 2, let's dive right into it, right? So I'm just going to go straight into Python or light up idle, and we'll go from there. Let me see. Out the shell. I'll just minimize this joker. I'll move it over here. Cool. So let's take a look. So what's a Boolean expression? It's nothing more than an expression that is either true or false. Could be any length, long, any wild operators. Is it true or false? Like you could say, is 5 equal to 5? Well, this is going to fail because equals is how you define a variable. Is 5 equal to is 2 equal signs followed by what you are comparing. So is the integer of 5 equal to the integer of 5? You hit enter, it comes back true. Well, true is also a built-in keyword in Python, so it's false. If you say 0 is equal to, let's do 1. 1 equal to, and we'll say true, it's true. 1 is also equal to true in Python, so that must mean 0 is equal to false, and that is true. 0 is indeed equal to false. 1 is indeed equal to true. They're both true. Now, can you say 1 is equal to false? That's false. That's not true because 0 is equal to false. These little tiny tips and tricks of Boolean operators will help you condense your code, write really good logic and comparisons once you learn how to leverage them, right? So you could say is true equal to true, and of course that's true. You could say is true equal to 1, you get true because 1 is true. Now if you say 2, you get a false because only 0 is false and 1 is true, right? The special places in Python. So all these fun-filled Boolean operators. And you could say is S equal to S true. Is 6 equal to the string of 7 false. So you could do all these fun-filled comparison operators. Well, how does that help you? Well, asking simple questions, getting input from users. Is today the 15th? And they say yes. And you compare the 15th to today's date and it equals false. Well, it's not. You could check time that way. You can get enter red, yellow, or green. If user input not equal to red or yellow or green, have them re-enter. You could do all kinds of fun stuff with if and comparison operators, which we're going to cover throughout the evening. But another important thing to do is take a look at the type of the word, the keyword of true. It has its own class of Boolean, so that comes with its own methods. It's its own object type, a Boolean object. So that's always fun, and you could set variables to true or false. A lot of people do like is true equal to true and things like that throughout their code. It depends on what I'm trying to complete with my code, but usually I just use the default true and false built into Python. It's relatively simple. And we discussed equal to, and we could say not equal to. Is 5 not equal to 5? So you see that that's before the equal sign, there's an exclamation point. That's saying not equal. When you hit enter, that's false because 5 indeed is equal to 5. Well, is 5 not equal to 4? Well, that's true because 5 is not equal to 4. So all these fun-filled comparisons, and within the book, there's also less than and greater than. Super helpful. But you got to remember that Python leverages the ASCII values of strings. So what does that mean? Well, if I do an A is greater than B, I get a false. Well, technically, these are strings. How is this false? How is A greater than B? Well, if you do an ordinal of A, it's a 97. And you do an ordinal of B, it's a 98. That's under the hood Python's actually comparing. It's the ASCII value of the string representation. So it's actually looking at the encoding, right? So that's something to keep in mind. Now, you could also do things like, is 3 less than 10 true? Awesome, right? These are awesome for comparisons. Like, if you have this many people in a crowd, do you need a bigger bus? True or false? Yes or no? You could do all kinds of fun-filled stuff with less than and greater than. Let's see, and you could also say less than or equal to. So 3 less than or equal to 3. Well, syntax here because I put a space, right? There we go. So 3 is less than or equal to 3. That comes back true. Well, 3 is equal to 3. But if we change this, say 1, that statement's true too. 1 is less than or equal to 3. It's less than. Sweet. So when you start the code and you understand that these comparison operators are there at your disposal, you can start to design your code, right? Like, let's take this for instance, like an if statement, right? So in reality, how if statements really work, let me just do this. Basically, it comes down to if this condition, we gotta spell it right. If this condition is met, let me close this up. If this condition is met, perform this statement. So you can either say perform this or do something, right? I think your book uses do something. Well, what happens if that condition is not met? Well, it's up to you to codify it, right? So you could use else if, and right again, you have another condition. So you could say, just hypothetically, is the color blue? Right? We'll walk through this in a second using this scenario. And it's always best practice. You can have as many else ifs as you want, by the way. Right? And you'll see a bunch of people do if, incorrect. Those are each individual statements, and you're not passing the same variable, or you're not passing the same mechanism down through the stack of if else ifs. You're actually going if, and you're checking each one individually. Big difference when Python does this. So let's say if blue is equal to red, or input, right? We'll gather someone's input. Is user input equal to blue? False. If it's false, if this condition is not met, it goes right to the else if statement. And then it goes, else if is blue equal to blue? True. Then it would perform this, never hitting the else statement. Now, some people take this same logic, which is correct, by using if, else if, and they make all these ifs. There's a problem here. Python's going to perform each one. Say if we want to be blue, if not blue, not met. If not red, not, it is red. It'll do this. But if this is red equal to yellow, if not equal to yellow, it'll perform each one. It's a waste of time, waste of input outputs. It's a waste of basic logic. You're not using it properly. The correct way is if blue, false. If blue is equal to blue, true, do this, and then it's moving down here to complete the rest of your code. It is highly efficient. This is not efficient. You're actually setting your variable to each condition. Bad. Totally bad. ChatGPT loves to give this back because you're using it incorrectly. But I digress. Your prompts are bad. This, however, is more optimal because once a condition is met that you've encoded, it leaves your if, else statement and moves throughout the rest of the code. I cannot stress that enough. This is bad. Right? This whole thing is bad. Absolutely horrible. This is common and efficient. So let's move on, right? So here we have a variable. We simply say num is -3. And now we're saying if -3 equal to 0, false, condition not met. Else if number greater than 0, false, not met. Well, it must be negative then. Print a negative number. Let's see if it works. Oh, unexpected indent, right? So let's do that. So now we have our script giving us back negative number. Well, let's walk through this. If -3 equal to 0, condition not met, Python never even passes that colon and goes down to the print 0. It goes right to the next statement. elif -3 greater than 0, false. Doesn't even go to the next statement, the print statement. Goes right to else, and it prints, this is a negative number. What if we change it to 0? And now we have, it prints 0. 0 equal to 0, true, this condition is met. It prints 0, it's done. And here, you see it, print 0, breaks out of the else if else statement, and it prints done. It doesn't even look at these other comparison operators, because once your operation is met within an if else if else statement, it does not keep going unless you code it to do that. But in reality, once a condition is met, it'll perform that statement and then move on. Awesome. Super helpful. And there's other things that walk in, and we'll talk about those right now. Let's see, let me pull up this one. Nah, it's no fun. I just did that. Any questions so far? The logic or the feel of if, else if, else statements? Here's one traveling a little longer. Here we grab some input from a user, put in an integer. They put an integer stored in X, then we compare it all the way down. And we have this else statement, nothing matched. Let's try that. Let's think of this though. Less than 0, so that'll be negative. So that'll catch all negative numbers. 0 is caught right here. Any equal to 1, okay, that's a single. And then anything greater than 1 is more. So when should this fire? Pretty much never if we lock it down to integers. And we want to have an integer because our comparisons are an integer to an integer. If we remove this int away, that parenthesis in this trailing one, input changes the default type of object to a string. So let's just cut and paste this and hack it up a little bit. Right. I'm gonna go ahead and just run it first so we know how it works. Enter an integer. If I put Tim, it'll break because invalid literal for integer. It's actually breaking right here. Tells you it has to be within base 10 and Tim is not. If I run it again and I say 33 and hit enter, well, 33 less than 0, false. 33 equal to 0, false. 33 equal to 1, false. 33 greater than 1, true, print more. And that's what happens, right? Well, let's take this away and see the errors we get when we attempt to grab input the same way. 33, enter, it breaks. Inputs changes the value type of your input. The object type, X, is now a string. And we can prove that by going type of X, and we'll see that it's a class string. And we call on X, it gives us 33 in quotes. That is why it is important to understand what types of objects you're comparing to each other. Now, if we go through this and flip it to the string, now you're comparing string values. You're no longer comparing the integer value, you're comparing the ASCII value of the string representation. Just keep that in mind, right? Always compare like objects when necessary, which is 99% of the time in this level, you want to do that. So do we want to go through any other steps on this or questions about if, else, if statements or before we move on? Everybody good? Sweet, pretty quiet tonight. Everybody sleepy? A little sleepy?
Yeah, I'm good.
Good stuff. Let's take a look at this. So you could also nest your logic. So what does that mean? There's a rule of there's an unsung rule in many programming languages that if you nest more than 3 times, your logic is incorrect. In other words, you can clean up the questions you want to ask before you nest 3 times. Well, what is nesting? Well, nesting is if your number is greater than or equal to 0, so that could be true if your number is 0 or greater than, and then you do a nested comparison. If number is equal to 0, print 0, else print positive. This if comparison operator followed by another if, and you can have logic in between here too if you needed, but for simplicity, if your number is greater than or equal to 0, right away, if number is equal to 0, print 0, else print positive number. And then instantly, if this is false, you know that the only thing left is a negative number. So there's ways you could nest all this. Necessarily, this is a very rudimentary, simplified version of nesting. A more advanced is enter your first and last name. So you could grab someone's first and last name. You could do if last name equals Smith, true. If first name equals Bob, else if first name equals William, else if first name equals Linda. You could programmatically figure out who Smith you're talking to. Linda Smith, Bob Smith, stuff like that. That's just a one of very almost infinite possibilities you could do with if and elif and else, which are super cool. Let's see where we're at. Yeah, nesting. We could nest all different types to do it, but let's run this and see how it operates. Let's save it. So enter a number. I'll enter 4.33, positive number. If 4.33 greater than 0, that condition is met. It is true. If number equal to 0, false. Else, print positive number. There we go. It's always important to pseudocode or talk out loud in the beginning of how you want to design your code and your logic map of your if, else if, and else statements. It helps you align your thoughts and how you want to run your logic. It also determines on what you want to compare too, right? But the more you do it, the easier it becomes. And once you learn these little operators of if, and else, you always have them at your disposal. Most languages that I know of have this type of statement, this comparison operator and Booleans. So this type of thinking can span over multiple languages other than Python, which is good, right? Now, in walks or and. Let's talk about and, right? So we're going to take this right here, enter a number. We're going to run with that. And we're going to say, let's do some comparison operator using and, right? So we're going to say, we're going to get a number from a user. And we're going to say, if the number, right, is greater than 0, now there's an operator, and now we're saying another statement, number, see if is greater than 0, and number, what can we say? If it's greater than 0 and less than 0, print must be 0. If it's greater than 0 and number less than 0, it must be 0. And we'll throw an else in here. So print not 0. Let's think of this for a second. Let's say we run this and we put in 5. If 5 greater than 0, true, and number less than 0, false. one of these, since it is not met, the entire statement is incorrect, and we will get not 0. Let's check this out, right? Please enter a number. I'm going to stick with the 5, not 0. 5 is greater than 0, true. And both, as many ands as you put together, every single comparison that you do has to equal true or be met in order to run that script block underneath your if statement. This is true, and 5 less than 0, false. This makes one false, makes that entire operation false. And then we get not 0. True, it is not 0. 5 is not 0. Well, what if I put 0? Well, 0 is not greater than 0, but we'll see how it operates, right? Not 0, even though it is. Well, the logic is incorrect. This is called a logic error. Python operated exactly how we designed it. If 0 greater than 0, false, not 0. The first time that Python meets a comparison operator that is false, it doesn't even perform the second operation. There's no way that this entire line could be true in order to do this operator when this is already false. So why bother moving forward? That's how efficient Python is. And you can use that to your benefit as you get wiser in your scripting, right? And I'll give you some hints as class rolls on and how to use that. So if 0 greater than 0, false, you're done. Is 0 less than 0? No. Well, it's not 0. So now you're starting to see how to program logic. Well, what if we say a negative number, right? Let's just run it. F5. We'll say -6. Hit enter. Well, it's not 0. Correct. -6 greater than 0. False. And number -6 less than 0. True. The minute it finds that one false, you're not 0. It never even performed that negative check because it knows that you're not greater. A little mind-bending, but it makes sense when you say it out loud and you think about it. So you could do ands. Now, and is saying both comparisons have to be met in order to perform this task or run the script block. Well, there's also an or. Or means one of these has to be correct. So let's take the same example we just did with -6. -6 greater than, false. Or, now it's going to perform both of them. And the entire operation has to be true. It'll quit at the first time it hits a false. Or we'll run the entire operation. Because -6 greater than 0, false. Or -6 less than 0, true. We're going to get a must be 0, but that's an output error, right? Must be 0 or negative. And this, not 0, it's a positive. Let's see if this works. We're going to run it. We're going to stick with our -6. I'm going to hit enter. Yep, correct. Must be 0 or negative. -6 greater than 0, false. Or one of these conditions has to be true in order for this script block to run. Very different from and, where both have to be met. Is that clear? Because and or are super powerful. And you could also do things like throw these in parentheses. Python doesn't care if these are in parentheses. It's actually easier to read for some folks. right? You could do that. It'll still run. Still operates the same. Now, what if we added some logic to that? What if we did an and? Well, you could do any combination of ors or ands you want. Just keep in mind the object that you're passing that next operator. Isn't that cool? We can get pretty tricky with these, and we will during our group project, especially the color one. There's some pretty cool. The color wheel one, that's a lot of fun. But any questions so far on ands or ors? Sweet. Now, there's another operator, the not statement. So, not is pretty unique by meaning you could say things like, well, let's just do it. It'll be fun, right? Let's do enter a number for, we'll just call this X, and enter a number for X. And we're going to copy this exact line, and we'll say Y. So now we're going to have a comparison between X or Y. We're going to get two integers or two floats from the user, and then we're going to compare them. If not X greater than Y, print now. If not X greater than Y. So what is that really saying? We'll just put test here for now, and we'll run our logic to see how it operates. Else, because it's okay to do things like this too. If you're unsure of how it's going to come out, run some print tests, figure out your logic, and go back and polish it up. Let's F5 this. Let's run it. Number for X, we'll say 5. Number for Y, we'll say 10. So I'm going to say, if not 5 greater than 10, if not, we got test. That's almost like a double negative in English. If not false. 5 greater than 10, false. If not false. Well, 2 nots equal true. No, don't think of it that way. Think of it as not true. Well, that's the condition you want. You don't want this to be true, so the condition is met, then it prints tests. Let's flip these. Let's do 10 greater than not 10 greater than Y, right? Well, we'll say 10 greater than 5. We're going to flip these. X is 10, 5, and now we get test 2. 10 greater than 5, true. Is it not true? Nope, it is not true because it's true, right? So that's why we get test 2. Not is programmatically expensive when you have a lot of objects. Here we only have 2. It's not that bad. When you say not, it has to check almost everything that you have in your list or your groups of objects to validate that you're not what you're comparing. So once you're not what you're comparing, your script block will run. So just be mindful that not exists. Sometimes it's a shorter route, right? Well, what does that mean? Well, what if you did a survey and your survey only had true and false questions and you're expecting 99% of people to say true? Well, if you say not true for question 1, you'll quickly programmatically zip through everything just to find the falses, right? You could do things like that. Sometimes not is what you want. Just be mindful of that, right? That's always fun. See, nesting conditionals with and, we've already discussed that. Let's see. Trying to think of where you can get stuck on this stuff. The best is just to do it, honestly. And the challenges beat you up a little bit. They run you through correcting a lot of logic and fixing some things. And by the end of the challenges and actually reading through the book and your fingers on the keys, you get a good feel for this stuff. And it's not that bad. But I don't want to go too overboard on this because the next part of this is output, like formatting output. We discussed this in lesson 1 with print a little bit with like the separator as well as the end, which I'm going to pivot from there. But does everybody feel sorta okay or kind of understand if, elif, and else, as well as greater than, less than, is equal to, not equal to, and or and not? That's a lot to take in, believe it or not. And or not equal to, greater than, less than, equal to, or equal to, or greater than, equal to, or less than, if, elif, else. That's a lot to take in already. It's well over 10 things. And to master these, they're simple, but the outcome of your logic could be so amazing with these simple things, which is pretty cool, right? If there's no questions, I'll go straight to print. I'll do help on print. You'll see when you do a help on print, it's a built-in function. You'll see right here, print, the value you want to print, and at the end has a couple things you could do. Has sep, default sep is a space, and default end is a new line. Well, let's prove that. Let's say print. Well, yep. Hard return makes a new line. Well, what if I did this, comma, end, and I say, well, how do we want to end it? Well, we could say end equals, quote, okay, so now we forced punctuation on our ending. All right. Oh, can you end it with different things? Like 3 hard returns? You sure can. You notice that first hard return here, second and third. So you can control how your print ends to give yourself more space in one line, as opposed to doing something. I'll go ahead and quote this out. Instead of doing something like this, print, we'll just say test, and then go print, new line, and then print this another time to get the same thing we have right here. You could do it in one line with using end, the parameter of end. This is the same as this, a little bit cleaner with using end. Just like if we use separate, like print, let's do ABC, we'll give it, now that's one object. I'm going to say separate equals with a dash. You notice it didn't put a dash in because ABC is one object. Now, if I did quote, comma, quote, comma, I'm messing this up. Now, if we separated each letter to give them each their own space or object identity, and we say separate with a dash, you're going to see that it separates each dash or it separates each object with a dash. Pretty different. And you can use them both at the same time. What if you wanted a dash at the end? Well, then you could end with a dash and force that C dash at the end right there. And now you end with a dash as well as sep with it. Cool stuff. Good to know, right? And once again, the more you leverage this, the more you use your \n, \t, and all these fun things, you become a master of output, basically, putting things to screen, right? And we discussed in lesson 1, our next topic, formatting numbers. Formatting numbers in Python, it appears to be black magic, but it's not. There's a format command, right? Help on format. And you see that format takes a value. Well, it could be any integer or float, and then it takes a specification. Well, you're like, what? What does that even mean? Now, when you look, this is the cool thing with Python. It's written by an open source community, so some of these built-in functions are indeed their own entire programs. Like format specifications is a mini language, and you can get help for that by typing help formatting. So we're going to go ahead and do that. 700 over 700 lines. So now you see it talks about how to format strings, gives you all these fun-filled things, all this wild stuff on how to align left and right, justify, more and more options. It just keeps going. I have never mastered everything in format because there is a ton of it to do. You can see that all the different ways you could format integers. Your book has, I think, like the top couple in there. Let's see. I think they have a couple in here. Yeah, they have the .2f and things like that. So we'll talk about that right now. Yeah, I'll do that example from the book. Cool. I'll go up here, give myself some more room. Let's take a tax rate, and we'll say 5.75, 5.75 tax rate %, right? So we got that, but we want to round it to 2. Well, that should go up to 5.8, right? Well, we want to round it. We want to only give two decimal places after the decimal point. A couple ways you could do that. I'm going to call on print, and you can do this within print, right? You can say tax rate. We'll just say tax rate. That'll just print out tax rate. And now we're going to call the format command. And we're going to format. It needs a value. So we're going to give it our variable of tax. And then it's followed by a specification, right? To focus on decimal place, 2 spaces to the right of the decimal place, format, close. So now format, value, specification for that value. Save it, hit F5. We should see, oh, you see it didn't round it though. It simply took the number and dropped it off. So be aware of the difference between format and rounding. You may have to perform some math functions properly prior to get what you want out of Python. But a big one in the book is they use the number of pi, and I think they use it to let's count how many they use. Let's see these all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Yeah, so 11 places, right? I think it's 11. And then they start throwing different ways to format it. Like, let's just, if you just want the whole numbers, I'm not going to go through them all in the book because it's kind of boring. But if you just wanted the 3, you're saying 0, I want 0 places to the right of the decimal point. So you'll just have a whole number up front, no matter what that is. Cool, right? Let's go ahead and print this. And you see that it prints 0 places to the right of the decimal point. So you can assume that if you do 1, 4, 5, 6, 7, it'll do just that, and you're correct. There's the 5. Let's do 4. Now look at that, it rounded it. Huh? Did it? Excuse me. So why didn't it round our text rate? Anybody know? Equal to 5. It's not greater than 5. Is that a problem? Let's go back up here and change this to 6. Remove this. Ah, there we go. So it has to be greater than 5 for it to round up. Not equal to 5, has to be greater than 5 for it to round up. So as we go through this, we're starting to see little behavior patterns of these individual tools, which is fine. That's how you learn, right? I wanted to highlight that. And those are the gist of mostly formatting. Then, so we're noticing that, let's say if this was not pi, but we'll say something like this, pi x, we'll call it pix, right? And we'll say that, yeah, we'll just keep 4. But there's no commas. It doesn't say 30,000, right? Well, the way to do that is, what if we throw a comma right there? Boop. So now we're saying comma separated. Comma separate our numbers left of the decimal place by the hundreds and thousands. And then we want 4 to the right of the decimal place. So that little comma adds that joker right there. Cool stuff, right? Let's see. And adding percent signs. Let's see if we got a test score. We'll say that's our test score. And we want it in whole numbers. And let's say this is 98. This is 98.14, right? And we want this as a percentage. And we would change this to 0, followed by the percent sign with no F. And now you'll see, oh, look at that. Look what it did. Why did it do that? Did it perform some math on it? Did it divide it by 100 or multiply it by 100? So be mindful of where your decimal point is and the math that this thing performs in order to get your percentage, because it does perform the math to leverage your percentage. Pretty cool, right? So in other words, if this was 5, boop, boop, 514, right? So just be aware. But this is your output. You'll have fun with the percentage stuff. You could manage it to comma separated too. Is like if you wanted a large number separated by comma, just put it in front. Of course, that's not it. What if we do this? Now you have 9,514%, stuff like that, just by adding that little comma. And you could take this 0% past, but what if we want 2 decimal places? And now you'll get your 1/6 right there. So you can have all kinds of formatting fun with Python. Don't get frustrated. It's easy to do. It really is easy to do. There's also another one that you could do base 10 really quickly. So if this was a whole number, I'll just remove this. And I'll take it down about that big. And instead of all this fun stuff, all you have to do is call on format, the value you want to format, comma, and then you want your specification of how you want to format. This is just a D. For what? Well, is it decimal or base 10? It's actually, I believe it's decimal integer. I believe it stands for decimal integer. And when you run it, it'll add your comma in every third integer. So you get your 9,514,159. You're not going to memorize all of those formatting specifications off the top of your head. You'll remember a couple key ones that you always use. I'll post a bunch of them in the announcements, like the top 10 or 25 that are commonly used, and we'll go through that. But there's a lot to cover in this lesson. It seems like a little bit. If, else, greater than, less than, equal to, not equal to. But remember, and or not are awesome. I'm just going to let you know right there. They are fantastic. And where you put them in your logic, where you leverage and or not inside your if statements can make your code 2 miles long or 3, 5 or 6 lines long. It really depends on how you operate your logic and what your goal is. But get used to using them, have a lot of fun doing it, and then format your output, right? If you start formatting your output now, it'll be second nature, and you'll always have nice looking output. That'll make it readable. No reason to have 16 decimal places unless you're doing some type of mapping or something, but things like that. But that's it for tonight. I'm going to go ahead and pause the recording here.